Hey, Algebra 2. So the other day we learned how to simplify and do laws of exponents. Today we are going to expand on that, and this time our exponents are going to be fractions. So here's a chart, and this is basically what we did the other day. It's been a while, but we have gone back and forth from rational exponents to radical form. So this is what it would look like. This is your rational exponent. And then the radical form looks something like this. So the denominator is the index. And then if it looks like this, that would be the same thing as the nth root of b to the m. And once again, the index is the denominator. So using this rule, we're going to write these in the different form. So x to the 1/9 is the same thing as the 9th root of x. So on this one, I have an x. The index is the denominator, so this would be raised to the exponent of 2/3. That is my index, so that is the 7th root of x squared. The index is an implied 2, and this would be the same thing as x to the 1/2. So we would like to simplify these expressions using positive exponents. So right here, when I am multiplying variables, you add your exponents. So we are going to add exponents here. So I have 4a to the 2/7 plus 4/7. On this one, you already have a common denominator. That's good. So I have 4a to the 6/7 would be your good final answer on that one. On this one, I do not have a common denominator, but when you multiply, you add your exponents together. So I have b to the 2/3 plus 3/8. You could get a common denominator, but we generally just use a calculator around here. So if you have this calculator, this one has a fraction button, so you would go 2/3, arrow over, plus 3/8, and that would give you 25/24. So this is b to the 25/24. Some of you have this calculator. So you could use the ABC button if you wanted to. You could go to ABC3 plus 3ABC8. And if it gives you it like this in a mixed number, you need to hit, it's that one. So above the ABC button, you're going to go second ABC, and that's how you put it into an improper fraction. An improper fraction is when the numerator is bigger than the denominator. Here we have an exponent raised to an exponent. When you have an exponent raised to an exponent, you multiply your exponents together. So I'm taking 2/3 times 2/1. There we go. We multiply fractions straight across, and you get 4/3. You could also enter that in your calculator if you wanted to. This is x to the 4/3. All right, I have a couple of different things going on here. If you have an exponent raised to an exponent, order of operations says that you have to do that one first. So I have 3/4 times 2/3. If I multiply straight across, I get 6/12, and I would reduce that to 1/2. So now I have x to the 1/2 times x to the 5/3. So now when you multiply, this is where you add your exponents. So now I have x to the 1/2 plus 5/3. To speed the process up, I entered that in my calculator, and I got x to the 13/6. In the next section, we are going to, there we go, divide them. So when you divide, this is when you subtract your exponents. So sometimes I don't know which one is bigger, so I'm just going to go top minus bottom. So I have 2/3 minus 1/6. Clear. So I put in 2/3 minus 1/6, and I get 1/2. So this would be x to the 1/2. All right, so I have two things going on here. You should clean up that numerator first. So the variables are being multiplied. So now I'm going to add my exponents together. So I have to figure out what is 3/2 plus 1/2. I'm not getting out my calculator for this because I already have a common denominator. I know that that's 4/2, and I know that that reduces to 2. So I would rewrite this as a squared divided by a. So now that they're being divided, now you're going to subtract your exponents. There's an implied 1 on that one. So when I go 2 minus 1, I get 1. So that answer is A. 11 is about the same, except this time I need to simplify my denominator first. So I'm going to add these exponents together. So I want 1/6 plus 1/2. Clear. 1/6 plus 1/2 is 2/3. So now I know I have x to the 1/3. That says 1/3, I promise. Divided by x to the 2/3. All right, so on this one, I recognize that my denominator is definitely bigger. And so we could, what I generally do is I take the bigger number minus the smaller number. So I know that I'm going to subtract that. When you cross it off, you always have a placeholder. So I know that I have a 1 on top. 2/3 minus 1/3 is 1/3. And so I get x to the 1/3. I might have to come back and double check myself on that one. Doesn't match my prior answer. All right, but number 12. So when you have an exponent raised to an exponent, that's when you're going to multiply them. So you have to distribute that to both of them. So I have 3/2 times 2/1. Those cancel out and you get 3. And then when you distribute it to the bottom, there's an implied 1 there, so that's just going to be a 2. So that means that I have m to the 3rd divided by m to the 2nd. And when you divide, you subtract, and therefore my good answer is m. This time, now I'm starting with them in radical form. All right, so a few units ago, I said that if you have different indexes, you aren't allowed to simplify them, but now we know better. If you have a different index, you are going to change to exponential form. So in the numerator, I have an implied index of 2. So the numerator is x to the 3/2. And then the denominator is x to the 2/3. So when you divide, you subtract. So I'm going to subtract 2/3 there. So in my calculator, I have 3/2 minus, what did I put there? Oh, must be something wrong with my calculator. Minus 2/3 equals 5/6. So I get x to the 5/6. The general rule of thumb is whatever form you start in, that's what you should end in. So I had to change form so that I could simplify this, but I really need it to end in radical. So the denominator is the index, and so that would be the 6th root of x to the 5th. Same thing on 14. I don't have the same index, so that first one is x to the 5/2. This one is x to the 7/3. When you multiply, you add exponents. So I'm taking 5/2 plus 7/3. Hold on. There we go. Oh dear, one moment. There we go. 5/2 plus 7/3 is 29/6. So I have x to the 29/6. And I need to put that back in radical form. And so that is the 6th root of x to the 29th. And I'm going to leave that alone. And then I have a couple with some negative exponents. So we said the other day that you fix negative exponents by flipping it. So that is implied to be over 1. I'm going to fix that negative exponent by sending that term to the denominator. So I have 81 to the 1/4, and I have a 1 in the numerator. You could stick this in your calculator if you wanted to. Some people find that the easiest thing to do. So in my calculator, type in 81 to the exponent of, in my calculator, I can do a fraction there. So I can go 1/4, and that answer is 3. So this is 1/3. If you have this calculator, you need to be a little bit more careful. Clear. I have 81 to the exponent. If you're going to do a fraction, you have got to use parentheses. And I can't remember if the ABC button works here or not, but it absolutely does. Or you could use division there. You could say 81 to the exponent, parenthesis, 1 divided by 4. And you still get 3. So that is 1/3. That is implied to be over 1, so I'm going to send that to the denominator. So I have 1/49 to the 1/2. If I change this into radical form, that would be the square root of 49. So if you have a denominator of 2, sometimes I just change it into radical form because then it becomes mental math, and I know that that is 7. Thank you so much.